Hello and welcome to today's problem 21, merge two sorted linked lists. So given the head of two sorted linked lists, list 1 and list 2, we have this example over here, and what we want to do is combine them together into one sorted list, and you can do that by splicing together the nodes of the first two lists over here. So given this 1 2 4 1 3 4, we want to produce this as output 1 1 2 3 4 4. If we take a look at the other cases over here, if we have two empty lists, we just want to return the combination of the two, which is also an empty list, and an empty linked list. And for the third example over here, if one is empty and the other is populated, we just want to return that populated list over here. So we know that list 1 and list 2 are sorted in non-decreasing order, which we can use as we think of a solution. One possible solution for this is that we can have, basically, we have these two linked lists over here, 1 2 4 and 1 3 4. What we can do is we can have a pointer at the very beginning of both of these linked lists over here. And since we're given the pointers to the head of both linked lists, what we can do is do a check to see whether or not one value is greater than the other. And if they're both equal, you want to arbitrarily set it to one value. So like in this case, we have 1 and 1. We can just choose, let's say, like the second list to default to. So we'll go ahead, and once we choose to see which one is greater, for the greater one, we want to set that. What we can do is we can have a dummy list, like a linked list. And what we can do is we can set the value of the head of that dummy linked list to the item of that, like basically the smaller of the pointers of those two items. So actually, instead of like having that be the head of the dummy linked list, what we can do is make a dummy node over here. So this node, and then have like the dummy linked node, linked list node point to the head of what we're going to return. So we'll have that point to the head. We're going to return. Now, okay, let me just comment this out in brackets over here. Okay, so just to run through what I'm talking about, what we do is first we have these two pointers. We check to see which one is greater out of the two. Well, 1 is equal to 1, so it doesn't matter. We just choose 1. What we do next is we move this pointer forward by 1, and then with our dummy 1, we'll have like a dummy list node over here, and then we'll have the dummy list node next value equal to whatever we just set over here. So we just like set that to 1, and then we go ahead and check do a comparison again. So we check to see which one is smaller out of the two pointers. Well, obviously 1 is smaller. So what we can do is we can set that dummy node's, like this one's next value, over to 1 again. So we'll go ahead, and then after that, after we set that, we move the pointer forward. We perform a check again to see which one is less than. It's 2. So after we do that, we do 2. Do another check again. After we move this pointer forward, we check, oh, okay, it's 3. We move this one forward, it's 4. And then we have 4 again as we move the pointers forward. So another thing that we can do actually is, since we have these, like an example of this that could be done is one being empty and one being populated, and like let's say like this one is like a larger one, like a larger list over here, like 5 6 etc. You don't want to just end off while like basically these two pointers exist. What if like one runs out to the very end and it doesn't catch anything? What we have to do afterwards is then like we have to check to see if the value still exists in either list 1 or list 2. Exist in either list 1 or list 2. If values exist in either list 1 or list 2, we want to return that one as the next value for our dummy one over here. So we want it to have, like at the very end, when one of the pointers reaches an end over here, we want to append the rest of the items. So like we have 5 or 6 over here, and then have that be our final result at the very end. So yeah, just to make things more clear, check to see which one is greater, then add least, smaller to dummy node, move pointer, And then at the very end, we want to check to see if the values exist in either list 1 or list 2. At the very end, what we can do is we can basically check to see the original, like the dummy node over here, and we can return the dummy's next value as the final merged linked list. So 3 return dummies next as final linked list. So if we go ahead and begin coding that up now, just for a clearer explanation, what we can do is we can set that dummy value, so dummy, and we can have that equal to the list node that we were talking about over here. Well, also what we need to do, we need to keep in mind that we have to keep track of what the head of the merged linked list is, and if we use the dummy and basically move it forward as we keep traversing through, it won't be good because then we won't have a reference to the very beginning. So what we can also do is we can have a variable also equal point to that original list node over there as well. So next thing we want to do is while list 1 and list 2, while there's items at the pointers that we're currently at, so we'll start off at the very beginning over here, what we want to do is we want to check to see whether or not list 1 value is less than or greater than list 2. So we can do if list1.val is less than list2.val, then what we can do is we can set the dummy or the current's next value either to list 1 or list 2, and because list 1 is smaller, we want to set list 1 as that final value over there, and then we can move list 1 and basically move that pointer to the next one. So list 1 equals list 1 dot next. If the other thing has occurred where list 2 is greater, then we want cur.next to obviously be list 2, and we want to set list 2 to equal list 2.next. And then, regardless of what happens here, we want to keep moving that dummy pointer forward so it generates the whole thing. So what we can do then is set the cur to equal the current.next over here. At the very end, what we can do is then return the dummy.next, like we were talking about before. We don't want to return the dummy because that's going to just return this empty list node. So we can do this over here at the very end in order to get our last value. Now, also another thing we need to watch out for is like the step 2, like we were talking about. Check to see if values exist in either list 1 or list 2. And then if so, if we want to set cur.next equal list 1 or list 2 if they exist, depending on which one exists after we complete the iteration where both of them exist. So if we go ahead and just check this one more time, we have basically dummy is equal to cur, which is equal to a list node, while list 1 and list 2 has items at those pointers, right? List 1 and list 2. We begin traversing forward, checking to see whether or not the values exist. If list 1 is less than list 2, we set that as the current next value, list 1, and then we traverse that pointer forward. Otherwise, we set the next one to equal list 2, whichever is that pointer forward. Regardless, we want to keep moving the cur pointer forward, and at the very end, when list 1 and list 2, when either one of them don't exist, we want to have the cur.next set to either list 1 or list 2, depending on what is existing, and then at the very end, return the final result. So if we go ahead and run this now, do a quick submission. And there we go, fully accepted. Thank you for watching.